In the problem illustrated here, we're going to use the central limit theorem for part B, but we don't have to use it for part A. So, first of all, we are told that we're picking Rice Krispie squares from a packaging line, and those Rice Krispie squares have got a mean weight. Each individual Rice Krispie square has a mean weight of 22.2 grams, and we're told that the standard deviation of the weights of the individual bars is 0.4. So I think we're told, or we're making the assumption, we're dealing with a normal distribution. So the center is at 22.2. And we are being asked, well, first of all, this distribution represents the distribution of all the individually wrapped Rice Krispie bars that come off the line. We're going to pick one bar. So n is equal to 1. And the question is, what's the probability that that one bar has a weight below what's stated on the bag? And on the bag it says the bars contain 22 grams. So I need to find the area to the left of 22, given an overall mean of 22.2 and a standard deviation of 0.4. Now, I don't have to use the central limit theorem in this problem because I'm picking one bar out of a population. So if I was doing this by hand, I would use my standard normal distribution tables, and I'd have to figure out what x score represents this value of x of 22. So formula for z is the value you're interested in, x, minus the mean of your distribution divided by your standard deviation. So x is 22. I'm subtracting that from the known mean of the weights of all the bars that come off the line. Divide that by 0.4. And I'm going to get a z-score of negative 0.5. So if I transpose this curve to the standard normal distribution where we're talking about z-scores, right here is z equals 0, and I want to know, let's say, I don't know, negative 0.5 is probably about right here, and I need to know what's the area to the left. So in answering my problem, I want to know what's the probability x is less than 22 grams, which is the same as asking myself what's the probability that z is less than negative 0.5. And if I go to my standard normal distribution tables, hang on now while I get them up. So going to my standard normal distribution tables, I've got here a table that shows me areas to the left of negative z. And if I scroll this down or up, whatever, hang on now, let's adjust this a little bit. Here's my negative 0.5, so negative 0.50, and the area to the left is 0.3085. So coming back in here, my answer now, according to the tables, is 0.3085, so a 30.85% chance. Now, if I was to go to Minitab and get my answer, I could get it directly. Alright, here I've got Minitab open, and the simplest way to answer this question is simply go to your Graph tab, use the probability distribution plot. We're going to view probability, say OK, and I already had some stuff thrown in here. So the mean of this distribution of individually wrapped bars is 22.2 with a standard deviation of 0.4. I go to the shaded area, I'm plugging in an x value. I want the area in the left tail, and I want to know what's the area to the left of an x value of 22 grams. And here it is. I get exactly the same answer, 0.3085, as if I was using the tables. Now, in the second part of the question, we're being told that we're picking boxes of 24 bars. You know how you can buy them in boxes of 24. So in this case, n is equal to 24. And the question is asking us, what is the probability that the average weight of those 24 burrs is less than what's stated on the package, and the value is 22. So I'm now not talking about taking one burr off the line. I'm talking about taking a box of burrs off the line and asking what's the probability that the average of those 24 burrs is less than 22. So now I got to change my distribution. I'm no longer talking about the distribution that's up here. Central limit theorem says that if I was to repeatedly take samples and plot up all those sample means, the mean of all those sample means is equal to the true mean of all the individuals in your population, and we were told that that's 22.2, but the standard deviation of the distribution of all those means is going to be something a lot smaller. How small? Well, it's given by this formula here. The known mean of all the the known standard deviation of all the individuals in the population, that's given to us as 0.4, divided by the square root of your sample size, and for us that's 24. Now that works out to a much smaller standard deviation, 0.08165, I believe. So it's like, you know, it's 10 times smaller than value in the first part of the question. Alright, but just like in the first part of the question, if I was working this out by hand, I'd want to know the z-score. But this time, my formula is going to look kind of the same, but kind of not the same, because I'm not talking about an individual x, I'm talking about an average x. And therefore, I got to subtract that from the average of all the averages, divided by the standard deviation of all those averages. So x bar is still going to be 22 in this problem. And the mean of my means is the same as my population mean of 22.2. But my standard deviation now a lot smaller at 0.08165. And if you work this out, you get a z-score of negative 2.45. So on our standard normal distribution, z of negative 2.45 is going to appear pretty far down in the bottom part of this curve. And this area right here is going to be a lot smaller than the area that I have up here. So again, coming over to the standard normal distribution, hang on. Okay, so here I got my standard normal distribution table. I'm looking for a z-score of negative 2.45. So there's the negative 2.4. I come over here to the 0.5. And so the value I'm looking for is 0.0071. Okay, so from the tables we just saw that, well, first of all, I'm looking for a probability that x bar is less than 22, which is the same as finding the probability that a z-score is less than negative 2.45. And using tables, we just found that to be 0.0071. as the answer. And again, if I were to use Minitab to get the answer, alright, using Minitab, again, I'm going to go to, well, in this case, I'm going to go to the last dialog box I had open. And the only thing I'm really changing here is the standard deviation, which is a lot smaller for samples of 24 than it is for individually wrapped bars. My shaded area is going to be the same. I want to find the area to the left of a mean of 22. And there's my Minitab answer, 0.007145. So that is that agrees with tables. Minitab is going to be more correct simply because it's keeping more significant digits than what tables do.